Welcome back to Pre-Algebra Chapter 5, Section 3 in this book. And this one is titled Adding and Subtracting Unlike Fractions. And what it's talking about is the denominator, or as I had a kid once call it, the demonator. So remember, what's on top is the numerator, what's on bottom is the denominator. And for fractions, they have to be the same denominator to add or subtract them. So last time, all the problems they gave us already had the same denominator, so they were pretty easy. But what do you do if they're not the same? Well, it depends on the situation. So this is our easiest situation here. The denominators are 12 and 3. And what you do first is you ask yourself, does 3 go into 12? If it does, then does the little one go into the big one? If it does, the big one is your new denominator. So my new denominator, 3, does go into 12. So 12 is I'm going to convert this to having a denominator of 12, and then I can do the problem. Okay, so number 1, ask yourself, does the little number go into the big number? Yes. So therefore, my denominator that I'm going with is the big one. Okay? Now, this is what I call a z problem, but I'm dyslexic and it's really a backward z, and I really only figured that out like 2 years ago. Alright, so we are still going to call them a z problem. So what you do is you do this. You say, how many times does 3 go into 12? So we divide. How many times does 3 go into 12? It goes 4 times. So we're going to multiply 4 times 1, and it equals 4. So 3 goes into 12 4 times. 4 times 1 is 4. See? To me that looks like a z, but my students tell me that's a backward z. So now I can do the problem. I can write this over here if that helps. You don't have to, but sometimes you like things up and down. 5 plus 4 is 9/12. I can reduce that. 3 goes into 9 3 times. 3 goes into 12 4 times. Okay, here's another one. Does 6 go into 9 evenly? No. So what do I do now? You skip count by 9s until you find one 6 goes into. What do I mean by skip count? 9, 18, like that. So, 9, 18, does 6 go into 18? Yes. So I'm going to do z problems with both of those with 18. So what we're actually doing is we are finding the least common multiple. Remember when we did that? Alright, so now we do the z problem. 9 goes into 18 2 times. 2 times 7 is 14. And this will be a negative 14. Now we're going to do this one. 6 goes into 18 3 times. 3 times 5 is 15. So, and this is negative 2. I do my math here, and it's negative and negative, so here's my denominator, 18. And if they're both negative, I'm adding them. I was negative, and now I'm going to be more negative. So 5 and 4 is 9, 1 and 1 is 2. And can that be reduced? Let's cheat and look in the book and see. No. But what they did is they converted it to, because 18 goes into 29, they converted it into 1, negative 1, and 11/18. Now, this is a fun little secret I'm going to tell you. In algebra, we prefer this answer. And once you hit algebra, you don't have to ever do that again, of straightening it out like that and making it a mixed number. We actually prefer improper fractions in algebra because it's ready to go. Where if I wanted to do more math with this, I'd have to do a C problem and turn it into improper. Alright, so that's a little something to look forward to with algebra. Okay, here's another one. Now notice how this is ugly. I don't like that. And plus a negative is the same thing as subtract. So I'm just going to change that to here. Now when you have a mixed number, there's 2 ways we can do it. Either we can do it the way we've been doing it, and we might have to end up borrowing with the whole numbers, or we can turn both of these into improper fractions and do it the way we've been doing it. I'll show you both ways. So I think I like the borrowing way better. So, does 5 go into 11? No. We count by 11s till we get what 5 goes into. 22, 33, 44, 55. Ding, ding, ding. It's 55. So we're going to make those our 55s. 11 goes into 55. 5 times 6 is 30. And 5 goes into 55. 5 times 11. 5 goes into 55. 11 times 2 is 22. So these are both negative, so I'm actually adding them together. So 55 on bottom, and 22 plus 30 is 52 on top. 4 plus 2 is 6. So that is the answer. I think that's a pretty good way to do it. Let's see if it can be reduced. Nope, that's the answer. I think that's the easiest way to do it. If you want to see the other way, it's in your book. They converted them both to improper fractions first. Alright, so here's another one. It's subtracting and it's mixed. So this I might need to borrow. This is what I'm going to show you. Okay, does 4 go into 5? No. So we count by 5 so we find one that 4 goes into. 10? Nope. 15? Nope. 20? Ding, ding, ding. That's it. So 20 is my new denominator, and I do my z problems. 4 goes into 20. 5 times 3 is 15. 5 goes into 20. 4 times 1 is 4. And this is subtracting. So can I do 4 minus 15? No, I can't. So I need to borrow one of this from 10, turn it into a 9, and add 20 twentieths to this, which would make that 24. Now I can do it. 24 minus 15 is 9 twentieths, and 9 minus 5 is 4. Can we reduce that? I don't think we can. Let's see if they, where is that, this one, make sure I'm doing, Yep, nope, that's the answer. I got it. No reducing needed. Alright, there is a way on your calculator to reduce fractions. So, if there's enough time, I'll show you maybe in a separate video. Alright, so now here's one. It's all crazy because it's got an x. X halves minus 6 halves. We're still going to do it the same way. Does 2 go into 6 evenly? Yes, it does. So 6 is our denominator. So we're going to do a z problem. 2 goes into 6 3 times. 3 times x is 3x. Ah, not so bad, is it? So we have 3x minus 1x is 2x over 6. Are we done? No, because 6 is made out of 2 times 3, so 2's can cancel out. So I'm left with x over 3, which is the same thing as 1x over 3, but we leave that 1 off because we're cool and we like the understood one. Alright, this will only make more sense if you practice it yourself. It's a whole different skill to watch me do it, so you do it, alright? Math is great. See you next time.